A very good morning to one and all. Today's topic is methods of contouring. In this section, we are going to see about the various methods of how we do a contouring. Let's move on. In methods of contouring, there are mainly two methods of locating contours. One is direct method, and second one is indirect method. Direct method. In this method, the contours to be located are directly traced out in the field by locating and marking a number of points on each contour. These points are then surveyed and plotted on the plan, and the contours are drawn through them. Here, the picture shows the direct method of contouring with a benchmark and the contour elevation. This method is most accurate but very slow and tedious and has a lot of time wasted in searching points of same elevation of a contour. This is suitable for small area and where great accuracy is required. There is also another method for doing direct method, so that is direct method by radial lines. Here, this method is suitable for small areas where a single point in the center can command the whole area. Radial lines are drawn from the common center by theodolite or compass, and their positions are fixed by horizontal angle and bearings. Temporary benchmarks are fixed at the center and the near ends of the radial lines. The contour points are then located and marked on these lines, and their positions are determined by measuring the distances along the radial lines. They are then plotted on the plan, and the contours are drawn by joining all the corresponding points with respect to the plane table instrument. Next is the indirect method. Indirect method, we have the first one as square method. In this method, the points are located and surveyed not necessarily by contour lines but the spot levels. Here, the spot levels of the several representative points are represented by representing hills, depressions, ridge, valley, and these portions are interpolated by interpolation, and the method is contouring by spot level method. Let's move on to the square method. In this method, the whole area is divided into a number of squares, the side of which is vary from 5 meter to 30 meter depending upon the nature of ground and the contour level. The square need not be same throughout. In this case, the corners of the squares are pegged out and the reduced level of these points are determined with the level. In the first thing, we could find the squares are laid along the ground and the contours are interpolated in the second figure. The important points in which the squares may be taken when required and located by the measurements from the corners, the squares are plotted and reduced level of the corners are written on the plan. Next is by cross sections. This method is more suitable for survey of long narrow strips such as road, railway or a canal. This method is suitable for the survey lines of long narrow strips of rail and this cross sections of are run traverse to the center line of work, and representative points are marked along the lines of the cross section. The cross sectional line need not necessarily be at right angles to the center line of the work. They may be inclined at any angle to the center line if necessary. The spacing of the cross section depends upon the topography and nature of survey. The common value is 20 meter to 30 meter in hilly and 100 meter in flat country. The levels of the points along the section lines are plotted in plan and contours are interpolated as shown in this figure. So this is how we do by the methods of cross sections. Next is by tachometric method. We see the stadia varies of the diaphragm. This method is more suitable in hilly areas. The number of stations in which can be commanded by a tachometer is far more than those levels, and thus the number of instrument settings are considerably reduced. A number of radial lines are laid down at a known angle interval, and representative paths are marked by pegs along these radial lines. Their elevations and distances are then calculated and plotted on the plan, and the contour lines are interpolated. Next, interpolation of contours. The process of spacing the contours proportionately between the plotted ground points is termed as interpolation. This becomes necessary in case of direct contouring And in the case of indirect contouring, as only the spot levels are taken in this method. While interpolation of contours, the ground between any two points is assumed to be uniformly sloping. What are the methods of interpolation? By estimation, by arithmetic calculation. By estimation, the position of the contour points between the ground points are estimated roughly, and the contours are then drawn by these points. This is a rough method and suitable for small scale maps. By arithmetic calculation, it's very tedious and accurate method and used in small areas where accurate results are necessary. The contours are interpolated as like this. Next is the graphical method. The figure shows the contour interval of 5 meter on a piercing tracing cloth and number of parallel lines are placed at 0.5 meter. We could saw that every 10th line will be made thick to ensure that there is a change in elevation. So this elevation points will be helpful in drawing the contours. So this is how we interpolate contours. Next is the uses of the contour map. Furnishes the features of the ground where it's flat, undulating or mountainous. From a contour map, sections may be easily drawn in any direction. Intervisibility can be ascertained. Suitable site selection of the road, railway, canal and pipeline can be done. A route for a given trade map can be traced on a map. Quantity of earthwork, catchment area and capacity of reservoir can be determined. So thank you all for your attention. Hope you have understood how to interpolate contour, what are the various methods involved in contouring and what are the uses of contour map. If you have any queries, kindly post the questions. Thank you for your attention. Thank you, one and all.